This video is on the work energy theorem. Question 1, state the equation for the work energy theorem. So work is equal to the change in kinetic energy. Remember, work is equal to F force S displacement cosine theta, theta being the angle between force and displacement. Question 2, a car with a mass of 1250 kilograms slows down from 35 meters per second to rest over a distance of 60 meters. Calculate the magnitude of the average force of friction on the car. So assume the car is moving to the right and the force of friction is to the left. So theta, the angle between the displacement and the force of friction, is going to be 180 degrees. So theta is 180 degrees. So we know V final is 0. We know V initial is 35. Solve for the force of friction. And then we get an answer. About 1.28 times 10 to the 4 newtons. Question 3. The front of a car with a mass of 955 kilograms and moving at 25 meters per second to the right is compressed by 0.255 meters when it collides with a wall. Calculate the average force on the front of the car from the wall. So the car is moving to the right and the force is to the left because it stops the car. So the angle between the displacement and the force is 180 degrees because they're in opposite directions. So theta is 180. V final is 0. So we could solve for force and get an answer. Question 4. A box with a mass of 8 kilograms is moving horizontally with a constant speed of 0.2 meters per second. Part A, calculate the kinetic energy of the box. We're going to use 1/2 mv squared. The box is then pushed horizontally with a force of 60 newtons with a friction force of 7 newtons. During this time, the box moves 3.25 meters. Calculate the net work done on the box. So work is equal to FD, and F is F net. So it's 60 minus 7. Part C, calculate the work done by the normal force, the force of gravity, the pushing force, and the friction force. Let's look at the force of gravity. The object goes to the right, force of gravity is down. That's 270 degrees. Because remember, theta equals 0 is east, and then positive theta is counterclockwise. So the cosine of 270 is 0. The angle between the displacement, which is to the right, and the normal force is 90 degrees. So the cosine of 90 is 0. So the work done by the normal force is 0. The force of push and the displacement is in the same direction. So that's 0 degrees. So force of push is to the right, displacement is to the right. The force of friction is to the left, the displacement is to the right. So that's 180 degrees. So the work done by friction is force of friction, 7 newtons, d the displacement, times the cosine of 180. Part D, calculate the speed of the box after 3.25 meters. Work is equal to Fs cosine theta, which is equal to the change in kinetic energy. So solve for V final. Plug in the numbers. Question 5. An elevator with a mass of 425 kilograms moves down with a speed of 3.75 meters per second. The elevator then begins to accelerate down with a constant acceleration of 6.25 meters per second squared for 15.5 meters. Part A, calculate the work done on the elevator by the force of gravity. So the elevator's displacement is down, the force of gravity points down, so they're both in the same direction, so theta is 0 degrees. So here we have mg s cosine theta. Part B, calculate the work done on the elevator by the force of tension. So first, calculate the force of tension. Sigma F equals ma. Force of gravity is positive, it points down, so positive y is down, negative y is up, so the force tension is up. Times mass times acceleration. Solve for force of tension. So this is when the elevator begins to accelerate down. Because the acceleration is 6.25 meters per second squared. Step 2, work is F s cosine theta. So we found force of tension from step 1. S is from the problem, it says 15.5 meters. Force of tension points up, S points down, so theta is 180 degrees. Part C, calculate the net work done on the elevator. Well, that's just going to be part A subtracted by part B. Part D, calculate the final speed of the elevator after it has fallen 15.5 meters. So we're going to use the equation work is equal to Fs cosine theta equals the change in kinetic energy. And solve for V final. Question 6, an elevator with a mass of 1250 kilograms moves up 35 meters with a constant speed of 8 meters per second. There is a friction force of 85 newtons. Part A, what is the total work done on the elevator? Work is equal to the change in kinetic energy, so that's 0 joules. Part B, calculate the work done by the force of tension. So step 1, calculate force of tension. So I'm going to say positive y is up. So sigma F sub y equals ma sub y equals plus force tension minus force of gravity minus force of friction equals 0. We know force of gravity is mg, and we know force of friction is 85 newtons. Step 2, we could use W, work is equal to Fs cosine theta. The force of tension is up, S is up, because it's moving upwards. So the angle is 0. So that's the cosine of 0 degrees. Part C, calculate the work done by the force of gravity. Work is equal to Fs cosine theta. So this is mg here. This is S. And theta is 180 degrees because force of gravity is down and the displacement is up. So that's 180 degrees. Part D, calculate the work done by the force of friction. Once again, the force of friction is down, the displacement is up. So that's 180 degrees. And the force is 85 newtons, the force of friction, and the distance it travels is 35 meters. Question 7. A 50 kilogram object is pulled 40 meters up a frictionless incline, which is 30 degrees above the horizontal. The object starts and ends at rest. If the object starts and ends at rest, that means the work done, which is the change in kinetic energy, is 0. Calculate the work done by the force of gravity. Well, work is equal to Fs cosine theta. F is the force of gravity, which is mg. S is 40 meters, and theta is 120 degrees because that's the angle between F and force of gravity and S. Part B, calculate the work done by the pulling force. So we know that the change in kinetic energy is 0, so the work is 0. Question 8, a man is pulling a block. The forces are shown below. We have force tension, force normal, force friction, force gravity, and we're given some values. Part A, calculate the work done by each force. So you could see the object moves to the right, and force of tension is 41.11 degrees. So the angle between force of tension and displacement is 41.11 degrees. The object moves to the right and the force normal is up. So the angle between force normal and the displacement is 90 degrees. The object moves to the right and force of friction is to the left. So the angle between friction and displacement is 180 degrees. Finally, the force of gravity is down, displacement is to the right. The angle between the two is 270 degrees. Part B, calculate the total work done on the block. So just add up all of these. You get 54,000 joules. Part C, calculate the change in kinetic energy of the block. Work is equal to the change in kinetic energy. So the same solution as B. Part D, the initial velocity of the block is 16 meters per second. Calculate its final velocity. So work is equal to the change in kinetic energy. So solve for V final. So we've already solved for the mass here and plug in all the values. Question 9. A block slides down an incline while a man is pulling it up the incline. The forces are shown below. Okay. Calculate the work done by each force. So you could see that the object moves down the incline. There's a force of tension up the incline. So theta is going to be 180 degrees minus 31.89 degrees. The normal force, it's going to be 90 degrees from the displacement by looking at the figure. The force of friction, it's going to be 180 degrees because the displacement is down the incline, the force of friction is up the incline. The force of gravity, it's going to be 90 degrees minus 36.87 degrees by looking at the image. Part B, calculate the total work done on the block. So just add up all of the solutions from part A. Part C, calculate the change in kinetic energy of the block. Work is equal to the change in kinetic energy. Same answer as B. Part D, the initial velocity of the block is 10. Calculate its final velocity. So first we calculate the mass. Second, we use the equation. And we got 14,400 joules from parts B and C. Question 10. Draw a graph of the kinetic energy of an object versus the work done on the object. E sub k versus W when a constant force acts on a mass which is initially at rest on a frictionless surface. So this is what it looks like. It's a line with a constant slope up. Question 11. The graph below shows how the net force acting on an object varies with the distance it has traveled. Determine the change in kinetic energy of an object after it has traveled 8 meters. So the work done is the area under a force versus displacement curve. So the work done is 27 joules. And work is equal to change in kinetic energy. Question 12. An object is pushed from rest along a smooth horizontal surface with a constant acceleration. Draw a graph of how the kinetic energy varies with the distance traveled. So work is equal to change in kinetic energy. And it's pulled from rest. So that's why we start at 0, 0.